Hello, in this video, we shall be covering acid, bases and salts chapter. We shall be covering properties of acid and bases, uses of acid and bases, indicators and salts. Let's learn them. Properties of acids and bases. Physical properties of acids and physical properties of bases. First, we shall learn about physical properties, then move on to the chemical properties. Physical properties of acid. It is sour in taste. It in aqueous solution. So, if you mix an acid in an aqueous solution, it will taste sour. Mineral acids. Examples are HCl, HNO3, H2SO4, which are highly corrosive. Examples are very important. In this chapter, examples are very important. Indicators. So, if we test an acid with the help of an indicator, it turns blue or a purple litmus to red in color. Moving on to physical properties of bases. Bases are bitter in taste when they are mixed in aqueous solution. Caustic alkalis such as KOH, NaOH are highly corrosive. Here mineral acids were there, here caustic alkalis are mentioned. In this case, indicator turns red litmus blue. So you see, this is opposite to that. Moving on to chemical properties of acids. Test for hydronium ions in a solution. Neutralization reactions. Acids neutralize bases to give salt and water only. So when acid is added to a base, it gets neutralized to give salt and water. That's it. No other product can be formed. If any other product is formed, then it is not a neutralization reaction. A base CuO, when added to an acid H2SO4, gives a salt, that is CuSO4 and water. Similarly, NaOH is a base which when added to HCl as an acid gives NaCl, which is a salt, and H2O as water. Moving on. Reaction of active metals and acids. Acids in this case are dilute. These are chemical properties. We have not moved ahead. We are still learning chemical properties. Acids react with active metals. Now, examples of active metals. Mg, Al, Zn, Fe, which is magnesium, aluminium, zinc and iron. Acids react with active metals to give hydrogen or to liberate hydrogen. Active metal, we've taken an example of zinc. You can take magnesium, aluminium or iron. When added to a dilute acid, remember, you have to write dilute if the acid is dilute and concentrated if it is concentrated. But if there is nothing mentioned in your textbook, then you may not write anything. 2HCl gives us salt, that is ZnCl2 and hydrogen H2. Reactions of chlorides, nitrates, bicarbonates and carbonates with acids. The less volatile acid displaces the more volatile acid on heating with salt. Less volatile acid is denoted by acid Roman 1. In this case, it is not actually denoted. In this case, it is not actually denoted by that Roman 1. Salt, NaCl plus acid. Over here, 1 is mentioned. So, it is a less volatile acid. H2SO4, which is conc, less than temperature 200 degrees Celsius, gives salt 2. NaHSO4 plus acid 2. HCl, hydrogen chloride. The same reaction, same kind of reactions are mentioned down. Chemical properties of bases. Earlier, we were learning the chemical properties, but of what? Of acids. Now, we shall be learning the chemical properties of bases. Test for hydroxide ions or hydroxyl ions. Acids, we had learned in the definition, hydronium ions were given. Over here, hydroxyl ions. Hence, we will be learning the test for hydroxyl ions. So, if you have a compound which contains hydroxyl ions, you get to know very easily कि ये base है. And if it has hydronium ions, that is H3O+, then you get to know very easily कि ये acid है. That is why we will test for hydroxyl and hydronium ions. Alkalis react with ammonium salts on heating to liberate ammonia. When an alkali or a kind of base reacts with ammonium salts, it gives ammonia. Remember, I had told you ammonium is NH4, ammonia is NH3. A less volatile base, example NaOH, displaces a more volatile base. We had learned a similar thing in acids part. Ammonium salt reacted with a base gives salt and base. Here there are two products formed in this reaction. One is ammonia, which we know it is going to be produced, and the second is H2O, that is water. Alkalis react with certain metallic salt solutions to precipitate insoluble hydroxides. So now we know that alkali is going to react with metallic salt solution to give a precipitate which is insoluble hydroxide. Let's see. A metallic salt added to a base in aqueous state to give salt and insoluble hydroxide. Look at these reactions. Do you remember anything? Yes, we have studied them in two chapters. One is practical chemistry and the second one is acid, bases and salt, chapter 3b, analytical chemistry. Let's move on to properties of acids and bases in case of neutralization. Neutralization ionic theory. The process due to which, now we have two parts. Hydrogen ions of an acid react completely or combine with hydroxyl ions. So here hydrogen ions are mentioned and here hydroxyl ions. I'm repeating, hydrogen ions of an acid react completely or combine with hydroxyl ions of a base to give salt and water only. That means acid plus base gives salt and water. We have already learned this. During neutralization, the hydrogen ion or proton from the acid is neutralized by what? By hydroxyl ions from the alkali to form a water molecule. Now this can be asked as a give reason that why does an hydrogen ion or a proton from an acid gets neutralized by hydroxyl ions? So your answer will be from to form a water molecule. Thus HCl donates all ion, that is proton, to the hydroxyl ions of NaOH, which accepts the proton forming water. So in these three lines, we have found two give reasons. The first one I have already mentioned, and the second one could be, does HCl donates a H plus ion or a proton to the hydroxyl ion of NaOH, which accepts the proton forming water. This means this is important because give reasons do come in our paper, don't they? Heat of neutralization. The amount of heat liberated when 1 gram equivalent of an acid or a base is completely neutralized. Acids and bases, their uses: eye wash, boric acid; food preservation, citric acid; ink stain remover, oxalic acid, and much more. These can be asked in the form of MCQ or short answers, but they can be asked. It is not that ये बहुत छोटे छोटे क्वेश्चन है, ये कौन ही पूछेगा, नहीं, ये भी पूछ सकते हैं. Reference is omitted because we have already learnt it previous year. This is just formation of acid rain. We had 2 full pages of this. Why to learn this much then? Moving on to indicators. Now, what do you mean by the term indicator? Without looking at this, if you can answer, you are very good at this. Indicators are weak organic compounds. Weak organic compounds, that is acid or bases, which change color in accordance with the pH of the solution. What is pH? pH is the level which determines if a solution or a compound or whatever, it is acidic or it is basic. Indicators dissociate slightly in solution, which produce ions and undissociated molecules. So indicators, this line which means undissociated molecules, it means that indicators do not dissociate completely. They do dissociate, but then they also produce undissociated molecules. The color of the ions produced is dependent on the hydrogen ion concentration of or pH of the medium. Now, pH value of a medium. Pure water is neutral and ionizes very slightly. Pure water is neutral, which means it is neither acidic nor basic. बीच में कहीं पे तो आता है. And वो slightly ionize होता है, very slightly. It does not ionize slightly, neither very much, very slightly. To yield what? To give equal number of hydrogen ions and the hydroxyl ions. So in a solution, if you see the number of hydrogen ions and the hydronium ions as equal, then that solution can be considered as neutral. Now this can be a give reason. Moving on, the concentration of hydrogen ions and hydroxyl ions are both equal to 10 to the power 7 mole dm, that is decimeter to the power minus 3 per decimeter cube at 25 degrees Celsius. This can be asked as a MCQ, and MCQ we want full marks, don't we? Now we have these two omitted. Moving on to this one. The pH value represents the strength of acid. I have already told you what is pH. pH determines if a solution is acidic or basic. And the pH value, it represents the strength of acids and alkalis, that is bases, expressed in terms of hydrogen concentration. pH is defined as the negative logarithm to the base 10 of hydrogen ion concentration expressed in mole per liter. pH is equal to minus log to the base 10 H plus, that is hydrogen ion. pH of pure water is 7. pH of pure water is 7. This indicates 7 is neutral because water, pure water is neutral, and if the pH of pure water is 7, that means 7 is neutral. So if any solution उसका pH अगर 7 है, that means it is neutral. pH 7 is neutral. pH less than 7, that is 6, 5, 4, 3, 2, 1 or whatever, is acidic, and more than 7 is basic. Now, determination of pH by the use of indicators. Wow, colorful. I like colored objects. Isn't it very attractive and nice? It is, right? You need not look at all this. This might confuse you. We can learn about methyl orange and phenolphthalein, color change and everything later on. This might confuse you. You may not look at this. Look at this first. If you see a green color, it means the pH value is 7. And if it is 7, it means it is neutral. Whereas if you see yellow, orange or red color, it means it is acidic. If it is yellow, it is slightly acidic. If it is orange, it is more than slightly acidic. And if it is red, it is extremely acidic. And just imagine if the number wouldn't have stopped to 0 and if it would have gone to minus, then how much acidic a substance could have been? If you see something blue, indigo or violet in color, it has a pH more than 7, which means it is basic. And basic is good. It is not harmful. But yes, if in excess, then it is harmful as well. You need some acid as well, don't you? You have HCl in your intestine, don't you? Now, how you can remember this is by Vibgyor. Vibgyor. We have learnt this. This is a short term we use for the rainbow colors. Do we? Now, types of indicators. Common acid-base indicator and universal indicator. These are very, very important. The main difference between both of them is common acid-base indicator determines the nature. Now, what do you mean by nature? This indicator determines कि ये चीज acidic है या ये basic है. But universal indicator determines the strength. It means अगर ये acidic है तो कितना है? 4, 3, 2 कितना? And अगर ये basic है तो क्या है? Blue what? Exactly what? So this is a major difference in between both of them. Now color change by indicators. You remember just previously I had told you methyl orange, phenolphthalein, इनका color change हम बाद में पढ़ लेंगे. अभी आप ये मत पढ़ो तो आप कंफ्यूज होगे. बस हम वो अभी पढ़ रहे हैं. Common acid base indicator, there is a color change. Now indicators हमारे पास बहुत सारे यहाँ पे listed है. That is litmus paper होता है, methyl orange है, phenolphthalein है and phenolphthalein alkaline type. Now color change. अगर लिटमस न्यूट्रल चीज से कांटेक्ट में लाया तो इट रिमेन्स पर्पल. ओके, इट रिमेन्स पर्पल. नाउ इफ इट इज इन कांटेक्ट विथ एन acidic substance, then it might change to red. And if it is in contact with an alkaline substance, it may change to blue. This will be asked. And let me tell you, क्या था और क्या हुआ. This is very important. So if you say, अगर आपको एक question पूछा है कि litmus अगर not in case of litmus, in case of methyl orange when in contact with acidic substance, what is the color change? You might write it changes pink in color. But from what? क्या था पहले? It was orange. I mean the name suggests it was orange and it is actually orange. आपको पहले न्यूट्रल का लिखना है. एंड अगर आपको पूछा है कि वो न्यूट्रल में ही क्या था तो दे माइट गिव यू कि एसिडिक से न्यूट्रल हुआ तो एसिडिक का बताना है कलर एंड देन न्यूट्रल का बताना है. बट इफ दे हैव ओनली गिवन यू लिटमस पेपर इन न्यूट्रल और मिथाइल ऑरेंज इन न्यूट्रल, then you will only write orange. Then you have nothing to write कि क्या था, क्या हुआ वही लिखना पड़ेगा. Methyl orange when in neutral gives orange, when in contact with acidic substance gives pink color, and alkaline gives yellow color. Phenolphthalein, it is colorless in neutral and acidic, but is pink when alkaline. तो इससे हमें ये समझा कि फिनोफ्थलीन जब अल्कलाइन सब्सटेंस के साथ होता है तो वो पिंक होता है, एंड फिनोफ्थलीन यहाँ पे नेक्स्ट अल्कलाइन है तो वो भी न्यूट्रल के साथ पिंक रहेगा, एसिडिक के साथ कलरलेस रहेगा एंड अल्कलाइन के साथ भी पिंक रहेगा. नाउ दिस सॉर्ट ऑफ शोज कि ये न्यूट्रल एसिडिक के बीच में कहीं पे आता है, दैट इज वाई वो कलरलेस रहता है. दिस इज द सेम थिंग विच वी स्टडीड, जस्ट दैट कि जब ये एक्सट्रीम रेड कलर का रहता है तो इट इज स्ट्रांगली एसिडिक, जब ये थोड़ा सा येलोइश ऑरेंज या स्लाइट ग्रीनिश येलो रहता है तो इट इज वीकली एसिडिक, एंड द वाइस वर्सा व्हेन इट इज ब्लू, इंडिगो और ग्रीनिश ब्लू, turquoise or anything, it is weakly alkaline, and extreme, that is violet or 14 pH, means it is strongly alkaline. Utility of indicators: pH values and pH values of some common substances. These both are not very important, but they are also not omitted. So why not to read it once? You know, this time there are so many changes in the board paper pattern, the rules. Let's read this once. Once you've read it and you've understood it, if at all a question arises, then you are able to answer. You cannot be blank, right? Let's move on to salts. Now we had already learned the definition of salt in the first page, in the first video. A salt is a compound which is formed by partial or complete replacement of what? Of replaceable hydrogen ion of an acid by metallic ion or ammonium ion. That is the basic radical. This is not biology wala radical. Chemistry wala radical and bio wala radical are different. केमिस्ट्री वाले रेडिकल में स्पेलिंग आता है RADCI. केमिस्ट्री वाले रेडिकल में स्पेलिंग इज RADICAL एंड बायो के लिए इट इज LE. सो रिमेंबर दिस इज केमिस्ट्री वाला रेडिकल. Here these are a few reactions which are quite common. NaOH plus H2SO4 gives NaHSO4 plus H2O, which is partial replacement, and complete replacement में यहाँ पे NaHSO4 बना था, यहाँ पे Na2SO4 बनेगा and यहाँ पे 2H2O बनेगा. That's it. Moving on to types or classification of salts. Acid salt and normal salt. अभी हमने यहाँ पे देखा था ये दो चीजें होती है. ये दो चीजें में से जब पार्शियल रिप्लेसमेंट ऑफ हाइड्रोजन आयंस होता है तो यहाँ पे H2O सिंगल रहता है, उसके बैलेंसिंग के लिए हम सिर्फ 1 यूज करते हैं, देयर इज नो 2. एंड इन केस ऑफ द सॉल्ट फॉर्म्ड NaHSO4 बनता है. सो इन द सॉल्ट देयर इज एन H, हाइड्रोजन, बट व्हेन द कंप्लीट रिप्लेसमेंट ऑफ हाइड्रोजन आयंस टेक्स प्लेस Na2SO4 बनता है. सो देयर इज नो H इन बिटवीन दैट सॉल्ट, एंड इन दिस केस यहाँ पे हम 2H2O यूज करते हैं, विच मीन्स बैलेंसिंग के लिए वी एडेड 2. बस यही है. एसिड सॉल्ट है तो NaHSO4 बनेगा, नॉर्मल सॉल्ट है तो Na2SO4 बनेगा. लुक, दीज आर नॉट दैट इम्पॉर्टेंट. इसमें से ऐसा कुछ क्वेश्चन पूछेंगे नहीं. आई मीन दे हैव नॉट क्वाइट अ फ्यू, देयर आर लॉट ऑफ एग्जाम्पल्स इन दिस चैप्टर एंड रिएक्शंस. They might not ask anything major from this difference, but what is for your understanding or for MCQ point of view is जब NaHSO4 है, HSO4 है और H है तो it is acid, and जब H नहीं है, Na2SO4 है, normal जो भी salt रहता है, that is normal salt. That's it. इतना ही है. But read करने में क्या जाता है? They might give some question. So might के लिए you study this. These are examples, and as I've mentioned so many times, examples are so much very important. You just need to learn it. Solubility of metallic salts. This is a table, which is finally a table comes, which is very important. इसमें क्या है जो ये very important है? इसमें examples है. नाउ यू माइट नो इस चैप्टर में एग्जाम्पल्स इतने सारे हैं एंड ये सारे एग्जाम्पल्स इतने इंपॉर्टेंट है, आपको हर एक एग्जाम्पल रटा हुआ होना चाहिए. सॉल्यूबल सॉल्ट्स के लिए नाउ हाउ टू रीड दिस टेबल, आई टेल यू दैट. हम पहले थर्ड वाले से स्टार्ट करते हैं. ऑल बाइकार्बोनेट्स आर सॉल्यूबल सॉल्ट्स विद द एक्सेप्शन ऑफ KHCO3, NaHCO3. These two are insoluble salts, that too in cold water. इसको ऐसे रीड करते हैं, बट जो फर्स्ट टू है ना, इसमें ऑल Na+, K+, NH4+ के जो भी सॉल्ट्स रहते हैं वो सारे सॉल्यूबल रहते हैं. सो देर आर नो इनसॉल्यूबल सॉल्ट्स इन केस ऑफ Na+, K+ एंड NH4+. सिमिलरली नाइट्रेट्स एंड नाइट्राइट्स के लिए these all are, इसके सारे salts they are soluble. All sulfates are soluble with the exception of PbSO4, AgSO4, CaSO4, BaSO4. All chlorides with the exception of PbCl2, AgCl2, HgCl. PbCl2 is soluble in hot water, but यहाँ पे हम cold water की बात कर रहे हैं तो it is insoluble. अब यहाँ पे जो सल्फाइड, कार्बोनेट, ऑक्साइड, हाइड्रोक्साइड एंड फॉस्फेट के जो भी सॉल्ट्स रहते हैं, दे आर ऑल इनसॉल्युबल. ऑल. दिस टेबल इज वेरी वेरी इंपॉर्टेंट. इट इज इंपॉर्टेंट इन द पॉइंट ऑफ व्यू ऑफ reactions, of MCQ, of short answer, of everything. It is very very important. It is super important. I am repeating, this is extremely important. With this, we end our video. I hope you liked it. And please share and subscribe this. Thank you.